In calculus and other branches of mathematical analysis, limits involving an algebraic combination of functions in an independent variable may often be evaluated by replacing these functions by their limits. If the expression obtained after this substitution does not give enough information to determine the original limit, it is said to take on an indeterminate form. The term was originally introduced by Cauchy's student Moigno in the middle of the 19th century. The indeterminate forms typically considered in the literature are denoted 0/0ths, infinity, infinity, 0 times infinity, infinity minus infinity, 0, 1 infinity and infinity 0. Discussion. The most common example of an indeterminate form occurs as the ratio of two functions, in which both of these functions tend to 0 in the limit, and is referred to as the indeterminate form 0/0ths. As x approaches 0, the ratios x, x3, x, and x2, x go to infinity, 1, and 0 respectively. In each case, if the limits of the numerator and denominator are substituted, the resulting expression is 0/0ths, which is undefined. So, in a manner of speaking, 0/0ths can take on the values 0, 1 or infinity, and it is possible to construct similar examples for which the limit is any particular value. More formally, the fact that the functions f and g both approach 0 as x approaches some limit point c is not enough information to evaluate the limit. Not every undefined algebraic expression corresponds to an indeterminate form. For example, the expression 1/0th is undefined as a real number but does not correspond to an indeterminate form, because any limit that gives rise to this form will diverge to infinity. An indeterminate form expression may have a value in some contexts. For example, if kappa is an infinite cardinal number, then expressions 0 kappa, 00, 1 kappa and kappa 0 are well defined in the context of cardinal arithmetic. See also 0 to the power of 0. Note that 0 to the power infinity is not an indeterminate form. Some examples and non-examples. Indeterminate form 0/0ths. The indeterminate form 0/0ths is particularly common in calculus because it often arises in the evaluation of derivatives using their limit. Definition. As mentioned above, while this is enough to show that 0/0ths is an indeterminate form, other examples with this indeterminate form include indirect substitution of the number that x approaches into any of these expressions shows that these are examples of the indeterminate form 0/0ths. But these limits take many different values. Any desired value can be obtained for this indeterminate form as follows. The value infinity can also be obtained. Indeterminate form 00. The following limits illustrate that the expression 00 is an indeterminate form. Thus, in general, knowing that n is not sufficient to calculate the limit if the functions f and g are analytic at c, and f is positive for ex sufficiently close to c, then the limit of fg will be 1. Otherwise, use the transformation in the table below to evaluate the limit. Expressions that are not indeterminate forms. The expression 1/0th is not commonly regarded as an indeterminate form because there is not an infinite range of values that f per gram could approach. Specifically, if f approaches 1 and g approaches 0, then f and g may be chosen so that f per gram approaches plus infinity, f per gram approaches minus infinity, or the limit fails to exist. In each case the absolute value, f per gram, approaches plus infinity, and so the quotient f per gram must diverge, in the sense of the extended real numbers. Similarly, any expression of the form a0, with a 0, is not an indeterminate form since a quotient giving rise to such an expression will always diverge. The expression 0 infinity is not an indeterminate form. The expression 0 plus infinity has the limiting value 0 for the given individual limits, and the expression 0 minus infinity is equivalent to 1/0th. Evaluating indeterminate forms. The adjective indeterminate does not imply that the limit does not exist, as many of the examples above show. For example, the expression x to x can be simplified to x at any point other than x equals 0. Thus, the limit of this expression as x approaches 0 is the limit of x, which is 0. Most of the other examples above can also be evaluated using algebraic simplification. Equivalent infinitesimal when two variables and converge to 0 at the same point, and they are called equivalent infinitesimal. For the evaluation of the indeterminate form 0/0ths, we can use the following equivalent infinitesimals. For example, here is a brief proof. Suppose there are two equivalent infinitesimals and L'Hopital's rule. L'Hopital's rule is a general method for evaluating the indeterminate forms 0/0ths and infinity. This rule states that where f and g are the derivatives of f and g, these derivatives will allow one to perform algebraic simplification and eventually evaluate the limit. L'Hopital's rule can also be applied to other indeterminate forms, using first an appropriate algebraic transformation. For example, to evaluate the form OO, the right-hand side is of the form infinity, so L'Hopital's rule applies to it. Note that this equation is valid because the natural logarithm is a continuous function. It is irrelevant how well behaved f and g may be as long as f is asymptotically positive. Although L'Hopital's rule applies both to 0/0ths and to infinity, one of these forms may be more useful than the other in a particular case. One can change between these forms, if necessary, by transforming f-program to list of indeterminate forms. The following table lists the most common indeterminate forms and the transformations for applying L'Hopital's rule.